We're doing lesson 6.1.2 today, and a little more practice with comparison mats. And our first task, we're going to do a little bit of a review and look at this first mat to decide which one has the greater value, mat A or mat B. So yesterday we learned our first step is just to identify what those two expressions are to begin with, and this is called the original expression. Okay, and the original expression, you would have x plus negative 3x. Then we can combine our 1's to get 5. And then we're adding a negative 1 at the end. So right now, I'm going to start calling this minus 1 instead of plus negative 1, which means basically the same thing, but I'm going to try to shorten it as much as I can on every step. All right, so on mat B, what do we have? We have x plus negative 3x, or we can now say minus 3x. I'll start doing that from now on. And then plus 2 minus 2. So this gives us, once we look at the 0 pairs that we can take off, this will give us another simplified expression. Once we take out the zeros, we are going to get a pair down here. This is a pair of zeros. We also have a pair of zeros up here, and they always look like two identical type of tiles but with different shades. Okay, now we look at mat B. We have a pair of zeros. Actually, we have two pairs of zeros. We have positive 2 and we have negative 2, which we can kind of see in these expressions right here. So if you look at the x's, we see that we have a positive x and a negative x, which could be taking out. Now, that step of 0 pairs gives us a new simplified expression. This is negative x plus 4, negative 2x plus 4. And on the right, we have just negative 2x. All right, so at this point, it might be a little bit obvious which one might be bigger. So let's go ahead and do our second legal move, which in this case was removing whatever they have in common, anything that matches on mat A and mat B. So our matching tiles, you see we have two negative x's on both sides. That means that we can remove them from both sides, not affecting the balance of whatever relationship those mats both have. So our step was minus 2x. We took away 2 x's from both sides, and that gives us a new expression. We have 4 on the left, and since no tiles are left on the right, we now have 0. Okay, so if this mat is 4 and this mat is 0, this one's obviously greater, and is greater by 4. So let's continue our practice with this second one. All right, let's start with the original expression, which gives us 4x minus 3x two positive 1's is plus 2, and we have 1, 2, 3 negative 1's. That gives us negative 3. Going over to mat B, we look at our x's. We have two matching positive x's, 1 negative x, and 2 positive 1's, 3 negative 1's. So that gives us plus 2 minus 3. All right, so now we have our original expression. We can now start doing our legal moves. Okay, so first legal move, we take out our zeros, and let's go. Here we have 3 negative x's and 3 positive x's. We can take those out in one shot. No more zeros. We do. We have a 1 and we have a negative 1. So we can take that out. And now on the right side, we have an x and a negative x. That is, those are opposites. We have a 1 and a negative 1, and a 1 and a negative 1. Those are zeros. Don't forget to slash out your zeros to show that that is a 0 pair. All right, no more 0 pairs on the left, no more 0 pairs on the right. That now gives us an x and a negative 1. So x minus 1 is what remains, and it looks like x minus 1 is also what's left on the right. So we see that both of those are identical. But we still have a legal move that we can do, just in case it might not be as obvious. We can still remove that x, and we can still remove this 1, which kind of leaves nothing on either mat. So we can put those in one step. We subtracted an x and a negative 1. So x minus 1 was subtracted. Okay, and this gives us 0 and 0 on both mats, which makes them equal. Right? Left side is 0, right side is 0. Okay, so we're going to look at this next one in a kind of different way, but start off with the same exact steps. Okay, we're starting with the original. 4x plus 3 minus 2. And on the right we have x plus 7. 0 pairs. No 0 pairs on the right. So once we do our zeros, we have 4x plus 1 and x plus 7. Okay, now our next legal move is going to be removing matching parts. So we can remove that. We can remove this guy, leaving us with 3x plus 1 and 7. But let's go ahead and remove these guys as well. So we are taking away x plus 1. We're taking away x, we're taking away a positive 1. So we're removing an x and a 1, which is x plus 1. Now that leaves us 3 x's, and on this side we have 6. Okay, now to decide which one is greater, which the first question is it always possible to determine in a comparison mat which one is greater? So can we tell which one is greater here? And the answer is no, because x is unknown. We have no idea what x is. It can be any number in the world. It can be a positive number, it can be a negative number. We just don't know. So we cannot tell which one is bigger. Now, let's pretend that mat A has a greater value. Okay, so we're pretending that 3x is greater than 6. Now, if that was true, what would x be equal to make that true? Okay, so that would be true if x is, possible values would be 3, 4, 5, and so on. So all these numbers, if we plug it in, 3 times 4 is greater than 6. 3 times 5 is greater than 6. All these numbers, when we plug in for x, will be greater than 6. And kind of narrows down to any number that's bigger than 2. Okay, because 3 times 2 is 6, so that would not be greater for mat A. So this would be any number bigger than 2. That would make 3x greater than 6. Okay, now we look at the other side of the argument. What if mat B was greater and mat B was smaller? So this part is smaller. 3x is less than 6. Then what would x have to equal? Okay, x can equal 1. 3 times 1 is 3, which is less than 6. So that will be true if x is 1. X can be 0, x can be -1, x can be those numbers, but they still cannot be 2. Okay, notice all these numbers are less than 2. So x can be any number smaller than 2. That would make this true. All right, and the next question is, in what other way can mat A and B be related other than mat A being greater than mat B being greater than mat A? Both of them can also be equal. Now, when would they be equal? What would make them? And I kind of mentioned it earlier. They would have the same value if x was equal to 2. All right, because 3 times 2, right, we're plugging in 2 for x. 3 times 2 is equal to 6. That would make it true. Okay, so we're going to look at these this next problem using this concept. Okay, so let's say we have these two mats, and we're trying to decide which one is bigger. Now, in order to do it, let's say we have to make only x tiles be on mat A. Okay, so in other words, we need to isolate the x tile. Okay, and this is a important word that we're going to be seeing a lot more in math from this moment on. Okay, so we're going to need to isolate the x. Okay, in other words, get it by itself. Right? Now, if we get the x by itself, then one thing has to happen. Well, what's next to the x that's keeping it from being by itself? We have these right here, which is 6 negatives, right? Because this expression is x minus 6, right? To get the x by itself, we need to just kind of, to get x by itself, that's what we need to get rid of or undo. So, we need to get rid of the 6. And how are we going to get rid of the 6, of the negative 6? One way we can do that is we can turn that into 0. That would just be x plus 0, and x plus 0 is just x. So how can we make this negative 6 equal to 0? Okay, so that's our goal. We need to make it 0. And this is how we're going to isolate it. Okay, so we add 6 to the negative 6. We all know that 0 pairs are just opposites, right? We have 2 positives and 2 negatives. That's a 0 pair. So we can add 6 to make it x plus 0. Now, this will kind of upset the balance, because remember, this comparison mat is kind of like a balanced scale. Whether they're equal or not, there is a certain relationship between. So if we add 6 to this side, we're going to go 1, 2, 3, 4, 5, 6. We're not going to bother doing the squares. We're just going to do the pluses to represent 1. Now that throws off the balance. So what do we need to do? Well, on the right side, we had 0. But if we're going to add 6 to the left side, to mat A, we have to add 6 to mat B to restore that balance. So 1, 2, 3, 4, 5, 6. added to both sides, just kind of restores that balance again. Okay, so we made this equal to 0. That's how we find out what we're adding to both sides. Now, what does that do to the left side? I have positive 6 and negative 6. This is now a 0. And that leaves x on the right, on the left, mat A. Mat B, we now have 6. So this being something that restored the balance makes this another legal move. Okay, and that legal move was we added matching tiles. In other words, identical tiles to both sides. Okay, and you have to make sure that you're adding it to both sides, or else it would not be a legal move. Okay, must be both sides to restore the balance. Okay, now the reason again, let me remind you, this keeps the relationship the same. All right, so let's go to this next side, this next problem. So our goal now is to get mat B to have the x only. Okay, so that means we're going to be getting rid of everything else. So let's start with our original. Okay, so we're starting with 4 on mat A, and then mat B we have x plus 8 plus negative 2, which we're now saying minus 2. All right, so our 0 pairs, nothing on the left, but on the right we have negative 2, positive 2, leaving us 4 and x plus 6. Okay, so we basically combine those two like terms, 8 and negative 2, to get 6. Okay, that's what we're doing off the tiles. Okay, then our next, remember we're trying to isolate. Okay, this is our new goal, is to now isolate the x on the right. Okay, that's our goal. Get it by itself. And how are we going to do that? So let's see. Our next step that we can do is we can take away 4 positives from both sides. We have 4 1s and we have 4 1s. So we're going to take that out. So we removed 4 from both sides, giving us 0 and x plus 2. Okay, now that makes this a little bit easier because we have less to work with. If we have a x plus 2, how do we get x by itself? These are the things we have to get rid of, right? We need to zero out, that's what I call it, out 2. How do we zero out 2? We're putting negative 2. Okay, so we're adding negative 2 to both sides. So once we add 2 to both sides, that makes this a 0 pair. This is a 0 pair. And we have negative 2 and x by itself. So we can kind of run down today's lesson then. So now that we achieved our goal and isolated it by zeroing out, let's look at all of our legal moves. Okay, so there are a total of 3 legal moves. Okay, and our 3 legal moves are, 1, we remove 0 pairs, and this is kind of the order in which we need to do them, or at least look to do them whether you have 0 pairs or not. If you don't have any 0 pairs, just skip over to step 2, which is remove matching tiles. Okay, and once we remove matching tiles, If we still don't have that x by itself, or the x isolated, we need to add matching tiles. Okay, and these are our 3 legal moves so far. Okay, and just keep in mind that matching means both sides.